Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 23 Graphical Representation. We'll understand graphical representation. We will be drawing histograms and ogives with examples and solve mini questions from exercise 23. Graphical representation. What are graphical representation? We have studied about graphs from our previous classes. Okay, in the class 9th, we have studied about graphs, histogram, polygon, bar graph, etc. we have studied. Okay, so this is something which is not new for you guys. I know that. Now, why do we need graphs actually? For example, in a class, there are 50 students. Okay, 50 students. When a class test is conducted, does all the students get the same mark? If they have copied, there are chances, but not that case. Every student will be getting different marks. Okay, brilliant students will be getting between 45 to 50. Maybe some students will be getting 50 marks. Okay, poor students will be scoring some 0 to 10 range. Maybe 1, 2, 5, something like that. Then there are average students who will be getting marks like 22, 30 or 32, 40 ranges. Okay, there are different students who will be scoring different marks. Let us take a mathematics exam was conducted and the marks of a few students. Let us take the marks of few students 10, 30, 36, 42, 8, 12, 25, 26, 45, 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are taking the case of 10 students. Okay. So, these 10 students have scored this marks. Out of 50, the exam was conducted. First student got 10 marks. So, this student, do we call it a poor student or a bright student? So, this is a poor student. Okay. 30 marks. Somewhat an average student. 36, again average. 42, bright student, right? 8. Below average, that is poor student. 12 is again below average. Now, if you are plotting this, just looking at these values, we can say that there are average students, there are poor students, there are bright students. So, when you have a graph, when you plot a graph, what we can just easily look at this graph and say in this class there are maximum number of average students, or in this class there are maximum number of brilliant students. If you are making a comparison between section, for us say 10th A, 10B, 10C. Okay, in 10A your graph was such that the average students are more. In 10B bright students are more, and in 10C poor students are more. That is just by comparing the marks. You are taking 10 students from each class. From each class you have taken 10 students, and in the same way you will check the marks. Okay, in this case we have more number of average students. So this 30, 36, then 25, 26, etc. will be in the average. Then there are only 2 or 3. This is 12 also can be included in the poor range. So 3 poor students, then bright 42, 45, 50. They are bright students. So in this class there are maximum number of average students, which means by plotting a graph we can easily understand the maximum is average student. So when it comes to the 10B class, here there are more brilliant students. Okay, more bright students are there. In that case they will be having marks between 40 to 50, maximum number of students. So by plotting that graph you will be getting the range being higher for bright students. When it comes to poor class, their marks range will be somewhat between 0 to 50. So, the graph will be higher at that case. Okay, 0 to 15 range, there will be greater values. So, here these graphical representation helps us to study some data. Okay, there are different methods which we will be studying today. Histograms and cumulative frequency curve or Ogive are what we are going to basically study in this class. We have studied about pie charts, then bar diagrams, etc. in our previous classes. You remember these? Yes. So, today's class we will be studying how to draw histogram, how to construct histogram for datas and also constructing cumulative frequency curves or ogives for the data. Understood? Let us start. Okay. First of all, what is a histogram? A histogram is a two-dimensional graphical representation of continuous frequency distribution. What does continuous frequency distribution mean? Just check these class intervals. Okay, so these are class intervals. Continuous frequency distribution means here we have lower limit and upper limit. When you take the interval 0 to 10, okay, this value is the lower limit and this value is the upper limit. Okay, in 0 to 10 interval, 0 is lower limit and 10 is upper limit. Next interval, what about 10 to 20, which is the lower limit? Yes, 10 is the lower limit and 20 is the upper limit. Next, 20 to 30, 20 is lower limit, 30 is upper limit. 30 to 40, 30 lower limit, 40 upper limit. 40 to 50, 40 is the lower limit and 50 is the upper limit. Now, when the upper limit of the first interval is equal to the lower limit of second interval. Now check this value. Here we have 10 as the upper limit of the first interval, and in the second interval, that is next consecutive interval, 10 is the lower limit, which means there is a continuity. Okay, same value is here. Okay, there is a continuity. Here we have 20, 20, 30, 30, 40, 40. Okay, upper limit of the first interval and the lower limit of second interval are equal. In that case, we call it continuous frequency distribution. Now, you have studied about bar graphs. Now, what is the difference between a bar graph and a histogram? This is how a histogram looks like. Okay, when you studied bar graph, they were like somewhat like this. Okay, so we use rectangles in order to represent bar graphs and histograms, but the difference is in case of bar graphs you will be having gaps. Gaps will be present in between. Okay, here this is a continuous representation. So continuous frequency distribution is represented in a histogram and this is how it looks like. Okay, so in this x-axis we will be taking the class interval. Class interval. Okay, so this is an example. So here 1 to 5 means this is starting from the 0 up to 5, 5 to 10. So here the upper limit and the lower limit of the next interval are same. 5 to 9 means from 5 to 9, 9 to 13, 13 to 17. So there is a continuity. Okay. When in case of bar graph, for example, you have a box. In the box there are a few number of balls. Okay. The color of these balls, let us say red colored balls, blue, green, yellow. This is what we have plotted. Okay. 2 red balls, 4 blue balls, 6 green balls, then 3 yellow balls. This is what we have plotted on a bar chart, okay, or bar graph. So here just the number of balls in red color, there is no continuity in this. Okay, we are just representing the data here. But when it comes to a histogram, there should be a continuity. This is a representation of continuous frequency distribution. Clear? Now, these rectangles are used to represent. So, just when you check these rectangles, when the area of the rectangle increases, how does area increases? So, here the intervals are same, which means this part, that is along the x-axis, let us say this is the length of the rectangles. Length of the rectangles are always same. What is the difference? Breadth is changing. Breadth is changing depending on the frequencies. So these are the frequencies. So depending on frequencies, the breadth is changing. When breadth changes, we know area of the rectangle also changes. Area of rectangle depends on the length and breadth. So here the class interval is proportional to the base. Okay, base is the x-axis and the frequency is proportional to the y-axis, that is the height of the rectangles. You can say the breadth or the height of the rectangles. So when the frequency increases, what happens? The area also increases. So depending, based on this, we can say which is greater. Okay, we can understand the graphs. Now let us take an example to draw a simple histogram. Here let us say there are some students whose marks in an examination is given. These are represented in the class interval 0 to 10 marks, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Next, the number of students, the frequencies 0 to 10, only one student. 10 to 20, one student again. 20 to 30, two students. Then 30 to 40, 3 students. 40 to 50, 2 students. So here we have taken 10 students. and their marks range are also given. So in order to plot a histogram, here you will be having the x-axis and this is the y-axis. So mark the axis first and this is the origin. On the x-axis we will be taking class interval. Okay. And on the y-axis we are taking the frequency. Okay, class interval. So we have starting from 0 to 10. So mark 10, 20, 30, 40, up to 50 we need. Next frequencies 1, 2 and 3. These are the values that we need. Okay, so we will be marking 1, 2, 3, 4, 5. Up to 3 is enough. So 3 should be included. Just remember that point. So between 0 to 10, there is only one student. So here this is how you will be marking. 0 to 10, 1 student. So 10 to 20, again 1. This is how the rectangle will be. 20 to 30, 2 students. Here we have 2. Okay, this is 2. 20 to 30. So this is the required rectangle. 20 to 30. 30 to 40, 3 students. So here we have 3. 30 to 40, 3 students. 40 to 50, 2 students. Here we have 2. So this is the histogram that we have constructed in order to draw a graph for the class intervals, that is marks of students. So we can understand from this class, if somebody asks you what is the range in which maximum students have scored in this class. Okay, what we can say, between the range 30 to 40, just by looking at this graph, because the area, when you check the area is greater for 30 to 40 range. So we can easily say that in the range 30 to 40, there are maximum number of students. Okay, now take a case, we are not including this 0 to 10. We don't know how many students are, we are not considering the data that comes between 0 to 10. Okay, so we have to just start from 10. In that case, what we'll be doing is, we just don't want to represent what is happening before 10. In that case, you will be using a mark like this. Okay, we'll explain it later. This mark is called a kink mark. This kink mark is used to represent data that are not included. If you are starting from 10, you don't know what is happening before 10. In that case, you will draw something, a zigzag line like this, and this is called a kink mark. Okay, now for example, you are starting from some 6,000. Okay, you have ranges 6,000, 6,500, 6,000, 7,000, 7,500. These are the ranges. So before 6,000, what is happening? We don't know. In that case, what you do? On the graph, here you will be having 6,000. This is 6,500. This is 7,000. Then 7,500. From 0 to 6,000, you don't know what is happening. So put a kink mark. Okay. This is how, just a zigzag line can be used to represent the kink mark. Clear? So this is a basic idea about a histogram. So these are the steps to be followed to draw a histogram for continuous grouped data. Okay, the first step is convert the data in the exclusive form if it is in the inclusive form. What are exclusive and inclusive form? If you have an interval given like, if you have an interval given like 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So this is the exclusive form. Okay, here there is a continuity, that is upper limit of the first interval and the lower limit of second interval are the same. Okay, for example, if you have 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49. This is how the interval is. In this case, there is no continuity. Here, the upper limit is 9 and in the second, the lower limit is 10. They are not the same. So, this is the inclusive form. Okay, so this inclusive form should be converted into exclusive form first. Okay, next. In order to convert this, you will be studying about an adjustment factor. We will be discussing about adjustment factor later. Taking suitable scales, mark class intervals on x-axis and frequencies on y-axis. So, to draw a histogram, you will be taking along the x-axis the class intervals. Then, frequencies will be taken on the y-axis, okay, with suitable scales, like we will be taking 1 centimeter is equal to 500 rupees or 1 centimeter is equal to 2 kg. So something like that. That is how the interval is, okay. Next is construct rectangles with class intervals as bases and corresponding frequencies as heights. So bases means the x-axis and y-axis represents the height. So you will be taking the frequencies along the y-axis and along the x-axis you will be taking the class interval. Okay, let us take an example. Draw histogram to represent the following. Here class interval and frequencies are given. 0 to 8, interval 0 to 8, the frequency is 6, 8 to 16, frequency 9, 16 to 24, frequency 12, 24 to 32, frequency 10, 32 to 40, frequency 5. Okay, so let us construct a histogram. First step is take the x and y axis. So this is the x axis and here we have y axis. On the x axis we are marking the class interval, right? Class interval. Y axis frequency. Okay. Now the interval 0 to 8, 8 to 16. So starting from 0, here we have 0, mark 8, then 16. After that you need 24, 32, up to 40 we need, up to 40. Okay. Similarly on the y-axis, we have 6, 9, 12, 10 and 5. Then how to mark? The maximum value, find the maximum value, that is 12. 12 should be included. The interval should be chosen in such a way that 12 should be included. So let us take 2, 4, 6, 8, 10, 12. 6, 8, 10, 12. Here 12 is also included. So first interval 0 to 8, the frequency is 6. How to mark? This is 0 to 8. Find where we have 6. Here we have 6. So draw a rectangle. This is the required rectangle. Next 8 to 16. 8 to 16, the frequency is 9. Find where we have 9. Here we have 9. So starting from 8 up to 16. Okay. 9. Next 16 to 24, it is 12. 16 to 24. Here we have 12. Okay. 16 to 24, 12. Next 24 to 32, it is 10. 24 to 32, 10. Mark. Then 32 to 40, we have 5. Somewhere here we have 5. So this is how you can construct a histogram. Understood? What is the first step? Here in this step, we have the exclusive form given. Exclusive, there is a continuity. Upper limit is 8 and the lower limit of the second interval is 8. They are same. That is, there is a continuity, so you don't have to convert it into any other form. Then frequencies are also given. Very simple. We have to construct a graph such that the class interval is taken along the x-axis and frequency along y-axis. Mark the values and then plot the graph. Understood? Now we know how to draw histograms for continuous group data. Now when it comes to discontinuous group data, how to draw? Here if you take an example, weight of some students are given and the number of students are given. Okay, 40 to 49, which means 40 is included, 49 is also included and values between 40 and 49 are included. 8. Okay, next 50 to 59. Starting from 50 up to 59, 59 and 50 are included. Values between them are also included. It is 6. Is there a continuity? So we know in the exclusive form, you will be having 50 here and 50 here. The values, that is upper limit of the first class and the lower limit of the very next class will be same. So here there is no continuity. The step is we have to convert the inclusive form to exclusive form. Okay. Now we'll study how to convert the inclusive form to exclusive form. This is inclusive form, that is the upper limit of the first class and the lower limit of the very next class are different. So when you convert this into exclusive form, the upper limit of first class and the lower limit of the very next class will be same. So for that you need an adjustment factor. So let's study what adjustment factor is. Okay, adjustment factor is something that we are adding to the upper limit and subtracting from the lower limit. So here we have some values. Yes, we have the intervals. We'll find an adjustment factor and add this adjustment factor to all these upper limits and subtract it from all these lower limit. Okay. Now how to find adjustment factors? Here, in order to find adjustment factor, there is a formula, that is half of lower limit of a class minus upper limit of previous class. Okay, if you are considering two classes, so take these two classes, we have to consider the upper limit of this class and the lower limit of this class. Okay, we have to subtract the upper limit of the first class from the lower limit of the second class when you are taking first and second class. So here with this example, we will be having half lower limit of the second class is 50, upper limit of the first class is 49. So 50 minus 49 into 1 by 2, half of it. Okay, 50 minus 49 is 1. Okay, 1 divided by 2, which is equal to 0.5. So you will have to subtract the 0.5 from every lower limits and add 0.5 to all the upper limits. Okay, 40 minus 0.5, you will be getting 39.5. 50 minus 0.5 is 49.5. 60 minus 0.5, 59.5. And 70 minus 0.5, 69.5. Now the upper limits, you are going to add this 0.5 adjustment factor to all the upper limits. 49 plus 0.5, 49.5. Here 59.5, 69.5, 79.5. Then the values, the frequencies. Frequencies are 8, 6, 11, 5. Okay. What is the change that have happened? When you added and subtracted, that is subtracted from the lower limits and added to the upper limit, what happened? Here the upper limit of the first class and the lower limit of second class had become equal. 49.5, 49.5. 59.5, 59.5. We can plot the histogram easily for the discontinuous group data. So this discontinuous group data is converted to a continuous form using the adjustment factor. Okay, using the adjustment factor we are converting, and then we can easily draw the required histogram. Okay, just let us roughly draw the histogram for this. X-axis, y-axis. X-axis we have weight, and y-axis we have frequency, that is number of students. Just a rough diagram. So here it is starting from 39.5. We need up to 79.5. Okay, I'll start from here. 39.5, then 49.5, 59.5, 69.5 and 79.5. Then the frequency values 8, 6, 11, 5. 11 should be included. So let us take 2, 4, 6, 8, 10, 12. Up to 12 is enough. Okay. Now, any values that is below this 39.5, we just don't need to mind. In that case, what we do? We just put a king mark here. Okay. We put that zigzag line because it represents below 39.5, whatever happens. That is weight below 39.5. We are not included. The data is not included. Okay. Now, 39.5 to 49.5, we have 8. So, here we have 8. This is how the rectangle looks. Then 49.5 to 59.5, it is 6. Here we have 6. 59.5 to 69.5, we have 11. Here we will be having 11. Okay. 69.5 to 79.5, we have 5. Between 4 and 6, we will be having 5. So this is how the graph, that is the histogram, looks. You should remember to put this mark because any values that is less than 39.5 will not be included. So from 0 to 39.5 is not included. So that is represented using this mark. Clear? This is how you can do histograms for discontinuous group data. Let us take an example for discontinuous group data, we are going to draw a histogram. Class intervals are given 11 to 20, 21 to 30, 31 to 40, 41 to 50 and 51 to 60. Okay, when you check this intervals, it is clear that it is discontinuous. Here the upper limit of the first interval is 20 and the lower limit of the second interval is 21, which they are different. Okay, so what we have to do, we have to make the upper limit of first interval and lower limit of second interval equal. What can be done? We have to find the adjustment factor. Adjustment factor. How to find adjustment factor? First, we have to take the lower limit of the second interval. Here, the lower limit of second interval is 21 minus upper limit of the first interval. It is not necessary that you take the first and second interval. You can take either second and third. That is the very next consecutive interval you have to take. Okay. Divided by 2. 21 minus 20 is equal to 1 divided by 2 and that is 0.5. Okay. So, we are going to add this 0.5 to all the upper limits and subtract 0.5 from all the lower limits. So, the table will be like this. Here you will be having class interval, inclusive, class interval, exclusive and then frequency. Okay. Class interval inclusive, that is given. First you have 11 to 20. Okay. When it is 11 to 20, what you are going to do to make it exclusive, we have to subtract 0.5 from the lower limit. 11 minus 0.5 is 10.5. 10.5 to 20 adding 0.5. This is the upper limit. So, 20.5. The remaining intervals are 21 to 30, 31 to 40, 41 to 50 and 51 to 60. So, these are the inclusive. Okay. Now, the exclusive form, you have to subtract 0.5 from lower limits and add 0.5 to the upper limits. So, you will be getting 20.5 to 30.5, 30.5 to 40.5, 40.5 to 50.5, 50.5 to 60.5. So, we got the exclusive form. Okay. Now, just check here the upper limit of the first interval and lower limit of second interval are equal. Upper limit of second interval is equal to the lower limit of third interval. Upper limit of the third interval is equal to lower limit of fourth interval. Upper limit of fourth interval is equal to the lower limit of fifth interval. Now, the frequencies. Frequencies 5, 8, 13, 10, 6. Now, you can easily draw the required histogram. So, to draw histogram, we will take the x and y axis. On the x axis, we will be taking the exclusive form class interval. Okay, here it is starting from 10.5 up to 60.5 we need values. What happens before 10.5 is not necessary. So, start with 10.5, from 0 to 10.5 put the tick mark, then 20.5, 30.5, 40.5, 50.5 and 60.5. Next, the frequencies are to be taken along the y-axis. So, frequency values 5, 8, 13, 10, 6. So, 13 is the highest value, 13 should be included. So, I will be taking the interval like this 2, 4, 6, 8, 10, 12, 40. Okay. Now, here consider the interval 10.5 to 20.5, the frequency is 5. 10.5 to 20.5, here we have 5. So, this is the rectangle. Next, 20.5 to 30.5, it is 8. Where do we have 8? Here we have 8. Okay. So, 20.5 to 30.5. Next, 30.5 to 40.5, we have 13. 13 is here. Okay. Between 12 and 14, we will be having 13. 40.5. This is it. Next, 40.5 to 50.5, we have 10. Here we have 10. Okay. Next, 50.5 to 60.5, it is 6. So, here we have 6. Okay. So, this is the required histogram. So, first step is converting the inclusive form, class interval to exclusive form. Only then you will be able to do. We have to convert the discontinuous data to a continuous form. Okay, third example is when class marks are given. Okay, here interval is not given, we have class marks given. When class marks are given, we will first find the class interval, that is lower limits and upper limits, and then we will be drawing the required histogram. Okay, here class mark 25, frequency 7, class mark 35, frequency 15, 45, 18, 55, 12 and 65, 8. Now, how to find the lower limit and upper limit? So, here we need an interval. Here we need an interval. Everywhere we need an interval. Okay. Now, when you find the difference between each class mark, what is the difference? Difference between the first two class marks. Here it is 35, here it is 25. The difference is equal to 10. Difference of class mark is equal to 10. Okay, just check the next two class marks, 45 and 35. Again it is 10. 45 minus 35 is 10. 55 minus 45 is 10. 65 minus 55 is also 10. So, in order to get the lower limit and upper limit, what you have to do is find the difference between two class mark and divide them by 2. Okay, on dividing 10 by 2, you will be getting 5. Next step, in order to get the lower limit and upper limit, what you have to do is, from this number, that is from this class mark, to get the lower limit, you will have to subtract 5. To get the upper limit, you will have to add 5. Okay, we have 25. Subtracting 5 from 25, we get the lower limit, which is equal to 20. And adding, you will be getting 30, and that is the upper limit. Okay, so let's find the class interval and frequency. For the first class mark, 25, you will be having 20 minus 5, 20, and the upper limit 25 plus 5, that is 30. So, next 35. 35 minus 5 is 30. 35 plus 5, that is 40. Next, 45. 45 minus 5, 40. 45 plus 5, that is 50. Next, 55. 55 minus 5, 50. 55 plus 5, 60. Next, 65. 65 minus 5, that is equal to 60. 65 plus 5 is equal to 70. Okay. So, these are the required class intervals. Now, we have frequencies 7, 15, 18, 12 and 8. We can now plot the required histogram. Okay. To plot the histogram, we have x-axis and y-axis. On the x-axis, we will be taking the class interval. Y-axis, frequency. So, class intervals. Here 20, 30, 40, 50, 60, 70 and all we need. Which means we will start with 20, 30, 40, 50, 60, 70. Okay. Any values that is less than 20 is not to be considered. We can put a king mark here. Okay. Then frequencies 7, 15, 18, 12, 8. Here 18 is the greatest value. 18 should be included. So, let's start with 2, 4, 6, 8, 10, 12, 14, 16, 18 up to 20. Okay. Now, we can easily draw. For interval 20 to 30, it is 7. 20 to 30, here we have 7. Okay. 30 to 40, it is 15. Here we have 15 between 14 and 16. 15. Next, 40 to 50, it is 18. 18. Here we have 18. 50 to 60, it is 12. Here we have 12. 60 to 70, we have 8. Here we have 8. Okay. So, these are the required values plotted and here our histogram is ready. Clear? This is when class marks are given. So, when class marks are given, first step is to find the class interval. For that, what you will be doing? The difference between the class marks will be taken and divided by 2. Then subtract from the class mark to get lower limit. Subtract from the class mark to get upper limit. I mean add with the class mark to get upper limit. Okay. Next, we need to understand what are cumulative frequencies and the cumulative frequency table. Okay. Here, cumulative frequency of a class interval is the sum of frequencies of all the classes up to this interval. With a simple example, I'll show you. That is, for example, the marks of a few students. That is, intervals are given 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Out of 50, the range in which the child's mark lies. Okay. Frequencies are given. What does this mean? In the range 0 to 10, between 0 to 10, 3 students have scored. Okay. Between 10 to 20, 4 students have scored. 20 to 30, 2 students. 30 to 40, 5 students. 40 to 50, 6 students. This is what frequency is. If I am asking you, what is the number of students who have scored marks less than 20? Less than 20, is it 4? No, right? 4 is when the number is less than 20 but greater than 10. I am asking you less than 20. In that case, 0 to 10 also will be included because 0 to 10, any value which lies between 0 to 10 is less than 20. So, in that case, you will have to add these two. Now, I am asking how many students have scored marks less than 40? What is the number of students? We know in the interval 30 to 40, 5 students. But we need students who have scored marks less than 40. In that, you will be having students who have scored between 0 to 10 because any number, 6. 6 is a number which is less than 40 and lies in the interval 0 to 10. Then you have to include 10 to 20, again 16. 16 is the marks that is lying between 10 to 20 and it is less than 40. 25. 25 is a number lying between 20 and 30 is less than 40. So that you will have to include all these. Okay. So adding all these 4, you will be getting marks, that is number of students, frequency less than 40. Okay. So here comes the idea of cumulative frequency. So to get cumulative frequency, what you have to do is you have to just sum it up. Okay. First frequency, here we have 3. So to get the next cumulative frequency, what you have to do is add these two. Okay. Which means the interval 0 to 20 interval it will be. Okay. Any mark that is less than 20 will be included here. 3 plus 4, that is 7. Next, to get the next cumulative frequency, that is anything less than 30. Okay. Between the interval 0 to 30 will be included here. We have to add this 2 to 7. Adding 2 to 7, you will be getting 9. To get the next one, next cumulative frequency less than 40, we'll add 5 to this. 9 plus 5, 14. To get the very next 40 to 50 interval, anything less than 50. You will have to add the 6. So, 20. So, there are total 20 students. That is, any student will be scoring mark which is less than 50 for the, if the exam is conducted for 50, can any student score a mark that is 65 greater than 50? No, right? So, all the 20 students, we have considered a class of 20 students. All the 20 students are getting marks which is less than 50. Okay. So, here when you check, this cumulative frequency will always be in the ascending order. That is, it is increasing because what we have done, we have just added. So, this is less than cumulative frequencies. Then you will have the more than cumulative frequencies or greater than cumulative frequencies. In that case, what is the difference? Just the intervals will be the same, like 0 to 10, 10 to 20, 20 to 30, 40. But in that case, you will be have to add because any student scoring marks more than 0 will be greater. Out of 50, every student will be scoring a mark which is more than 0. Then when it comes to 10 to range, what happens? There 0 to 10 should be excluded. Why? Because these students are not scoring more than 10. So that is how more than frequencies come. In that case, what you do is you just keep on subtracting. Okay. So here we have added. In that case, it will be subtraction. So we will go in detail. Now just understand what cumulative frequency is. So by now we know what are cumulative frequencies and know how to find cumulative frequencies. Let us draw a cumulative frequency curve, or it is also called an ogive. Okay. Here class intervals and frequencies, just the data that we have used just before. Class interval and frequencies are given. We have to find cumulative frequency. What are the cumulative frequency? Here you will be having 3. 3 plus 4, 7. 7 plus 2, 9. 9 plus 5, 14. 14 plus 6, 20. Okay. We have taken 20 as the total frequencies. Here, in order to draw a cumulative frequency curve or an ogive, first step is draw the x and y axis. Okay. Along x axis, we are taking the class interval. class interval. And along the y-axis, we will be taking the cumulative frequency. To draw a cumulative frequency curve, you should take the cumulative frequency along the y-axis. Cumulative frequency. Okay, now take the upper limits of the class intervals along the x-axis. Mark the points here 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. Next, mark the cumulative frequencies. We know that cumulative frequency goes on increasing. So, here we have 3, 7, 9, 14 and 20. We need values up to 20. So, that will be taking 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Okay. So, first is we have to mark the points with the upper limit of each interval and the corresponding cumulative frequency. Here the upper limit is 10 and the corresponding cumulative frequency is 3. 10, 3. Here we have 3. Mark the point. Next, 20. Upper limit is 20 and the cumulative frequency is 7. Here between 6 and 8 you will be having 7. The point is here. Next, 30. 30 upper limit. The cumulative frequency is 9. Here between 8 and 10 you will be having 9 at 30, 9. Then at 40 you have 14. 40 is here and 14 is here. So here you will be getting the point. Next 50. At 50 upper limit you have cumulative frequency 20. This is 20 and here we have 50. Mark the point. Join this with the freehand curve. Remember, it is a freehand curve. You don't need to use any scale or anything like that. Just freely you have to just mark the points. The marked points you have to join. This is the required cumulative frequency curve or the Ogive. Understood how to draw? We are taking the upper limits of the class intervals and the corresponding cumulative frequency. So, first step is when frequencies are given, you have to add it up and find the cumulative frequencies. Then you can easily plot the cumulative frequency curve. Okay, let us take an example. Example 4, draw a cumulative frequency curve for the following distribution. Marks and number of students are given. From 5 to 10, interval, number of students is 7. 10 to 15, 9 students. 15 to 20, 12 students. 20 to 25, 8 students. 25 to 30, 6 students. Okay, so in order to plot, first we need to find the cumulative frequency. Given marks, then number of students, which are the frequencies. We need to find the cumulative frequency first. Okay, for the marks, 5 to 10, then 10 to 15, 15 to 20, 20 to 25, 25 to 30. Okay, frequencies are 7, 9, 12, 8 and 6. Next, we need the cumulative frequency. Here, the cumulative frequency is 7. For the interval 10 to 15, there in order to get the cumulative frequency, you have to add these two numbers. 9 plus 7, you will be getting 16. Next, 16 plus 12, 28. 28 plus 8, 34. 34 plus 6, 40. So, the total number of students is equal to 40. Okay, we got the cumulative frequency. Now, we know how to draw the cumulative frequency curve. Take the x and y axis. Along the x-axis, we are taking marks. Okay. Then along the y-axis, we have number of students. Now here the interval is starting. The lower limit of the first interval is 5. It is not 0. In that case, whatever happens before 5 is not considered. Which means we have to start the lower limit 5 here. 0 to 5 we don't have any values. Okay. So that we'll be putting a king mark here. Okay. Then up to the upper limit of the last interval should be considered. 5, 10, 15, 20, 25 and 30. Okay. So the first point or the cumulative frequency curve will start from a point on the x-axis. Clear? Now, we have the cumulative frequencies. The highest value is 40. 40 should be included. So, that let us take the interval 5, 10, 15, 20, 25, 30, 35, 40. Okay. Now, here we have the lower limit 5 and the upper limit should be considered. For the upper limit 10, what is the value? We have 7. Upper limit of the first class is 10 and the cumulative frequency is 7. So, corresponding to 10, we should take 7. Here we have 7. This is the point. Next, 15. Here it is. Cumulative frequency is 16. Upper limit 15. Cumulative frequency 16. Here we will be having 16. Next, upper limit 20. Cumulative frequency 28. Here we have 20. Somewhere here we will be having 28. Okay. Upper limit 25. What is the cumulative frequency? 34. So, 34 lies between 30 and 35. Somewhere close to 35. So, 34 is here. 25. This is a point. Next, 30. Upper limit 30. Cumulative frequency is 40. Here we have 40 for 30. Okay. Now, join. Start from the lower limit, which is a point on x-axis. Lower limit of the first class. Okay. Start from here. Join all the points. So, this is the required cumulative frequency curve. Understood how we have done this? Clear? Let us now solve problems from exercise 23. Problem 1, question 1 of exercise 23. Draw histograms for the following frequency distributions. Here we have the first one. Class interval and frequency is given. For the class interval 0 to 10, we have frequency 12. 10 to 20, frequency 20, 20 to 30, frequency 26, 30 to 40, 18, 40 to 50, 10 and 50 to 60, 6. Okay, you can create a table with class interval and frequency. So, this is the required data. Let's draw the histogram. Okay, here we have x-axis and y-axis. On the x-axis, we will be taking class interval. Class interval. What about y-axis? Y-axis will be having the frequency. Okay. Frequency. Now, the class interval 0 to 10, 10 to 20. So, we can take an interval of 10. 0. Here we have 0, 10, 20, 30, 40, 50, up to 60 we need. Okay. 60, you can even take 70, that is okay. Then, frequency 12, 20, 26, 18, 10, 6. Okay. Let us take an interval of 5. 5, 10, 15, 20, 25 and 30. Okay. Now, check the highest value. Here the highest value is 26. Even 26 should be included within this axis. Okay. 0 to 10. 0 to 10, the frequency is 12. Here we have the interval 0 to 10. Where do we have 12? Here we have 10 and 12 will be somewhere here. Okay. So, up to 0 to 10, this is 12 and this is how it looks. Okay. Create the rectangular table. Then, 10 to 20. 10 to 20, it is 20. Where do we have 20? Here we have 20. So, this is how it looks. Now, 20 to 30. 20 to 30, it is 26. Where do we have 26? We have 25 here. 26 is just above that. Okay. Here we will be having 26. 20 to 30, we have 26. Next, 30 to 40, it is 18. Okay. 30 to 40, 18. 18 comes between 15 and 20. So, somewhere here. Okay. So, 30 to 40, we have 18. Next, 40 to 50. 40 to 50, it is 10. Here we have 10. Okay. This is 10. 40 to 50, 10. 50 to 60, it is 6. Here we have 5 and this is 6. So, 50 to 60, it is 6. So, this is the required histogram. We are taking class interval along the x-axis and the frequency along y-axis, marking the values, marking the intervals on x and y-axis, after which with this rectangular boxes we are constructing the histogram. Okay, very easy, right? Sub question 4 of question 1. Draw histogram for the following frequency distribution. Here class mark is given. It is not class interval. Class mark is given and frequency is given. For the class mark 16, frequency is 8, 24, 12, 32, 15, 40, 18, 48, 25, 56, 19 and 64, 10. So we need to construct a table. Here class mark is given. We need class interval. And then frequency is given. Frequency. Okay. Class mark, class interval and frequency. Given class marks 16, 24, 32, 40, 48, 56 and 64. Okay. Now we have to take intervals. Let's suppose 12 to 20. 12 to 20 is an interval and 16 lies between 12 and 20. Next I am taking 20 to 28. The height or the size of the interval is 8. Okay. 20 to 28. 24 lies between 20 and 28. Next 28 to 36. 32 lies between 28 and 36. 36 to 44. 40 lies between 36 and 44. 44 to 52. 48. We have 48 between 44 and 52. Next, 52 to 60. 56 lies between them. And 60 to 68. Okay. So, we have taken the interval. Next, the frequency is given 8, 12, 15, 18, 25, 19 and 10. Okay. Now let's draw the histogram with the class interval on x-axis and frequency on the y-axis. Now let us draw the histogram. So here we have the x and y-axis. On the x-axis we are taking class interval. Okay, you have to mark this class interval along the x-axis and on y-axis we have frequency. Frequency. Okay. The interval starts from 12. Okay. So, from 0 to 12, you will put some mark like this. This is called a king mark. Okay. This king mark is used when some large value lies before the lower limit of the first interval. Okay. We have 0 to 12. To represent that 0 to 12, we use this king mark. Next, we will start from 12. Then we have 20, 28, 36, 44, 52, 60 and 68. Okay. Next, the frequency. Frequency, check the highest value. Highest value is 25. 25 should be included in the interval. Okay. So, I'll start with 5, 10, 15, 20, 25, 30. That is 25 is included. So, the first interval 12 to 20. 12 to 20, the frequency is 8. Where do we have 8? 8 comes somewhere here. Okay. So, this is it. Next, 20 to 28. 20 to 28, it is 12. Where do we have 12? Between 10 and 15, we'll be having 12 somewhere here. Okay. So, on the graph paper, you can easily draw this. Next, 28 to 36, it is 15. Here we have 15. Next, 36 to 44, it is 18. 18 lies between 15 and 20. So, somewhere here you will be having 18. Next, 44 to 52. 44 to 52, it is 25. Here, 25, we have 25. So, this is it. Then, 52 to 60, it is 19. Where do we have 19? 19 lies between 15 and 20, just below 20. Okay, here we have 20. So, just below 20, somewhere here you will be having 52 to 60. Next, 60 to 68, it is 10. 10. Here we have 10. Okay. So, this is the required histogram. Understood what we have done? When class marks are given, we have to make class interval. Make a table with class interval. Okay. After that, for each class interval, represent the required frequencies. You should use a king mark in case some large values lies before the lower limit of the first interval. Clear? Here we have the second problem. Question 2 of exercise 23. Draw a cumulative frequency curve or ogive for the following frequency distributions. Class interval and frequencies are given. 10 to 15 frequency is 10. 15 to 20 frequency is 15. 20 to 25 frequency 17. 25 to 30 frequency 12. 30 to 35 10. And 35 to 40 8. So these are the frequencies. Now let us draw the cumulative frequency curve. Okay. For that, we have the x-axis and y-axis. On the x-axis, we will be taking the class interval. Class interval on x-axis. And on y-axis, we have frequency. Okay. Now let us take the values. Here, it is starting from 10 up to 40, we have values. So, we will start with 10, 15, 20, 25, 30, 35, 40. Okay. Here we have 10, 15, 17, 12, 10 and 8. The highest value is 17. Okay. So, 17 should be included in this. Let us take an interval of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. Now, let us take the values. So, here first we will be constructing a histogram. For 10 to 15, the frequency is 10. 10 to 15, frequency 10. So, this is how it looks. Okay, we are making the histogram. Next, 15 to 20. 15 to 20, it is 15. So, where do we have 15? Here, between 14 and 16, we will be having 15. Okay. So, here we have 15. This is for 15 to 20. Next, 20 to 25, we have 17. 17. Where do we have 17? Between 16 and 18, we have 17. Somewhere here. Okay. Between 20 to 25, we get 17. 25 to 30, it is 12. Where do we have 12? Here we have 12. Okay. It is between 25 to 30. 25 to 30. Next, for 30 to 35, we have 10. Here we have 10. Okay. 30 to 35, it is 10. Next, 35 to 40, we have 8. Here we have 8. Okay. This is 8. 35 to 40, we get 8. So, these are the histogram. What we need is cumulative frequency curve. Okay. Now, what we are going to do is take the middle of all these. Okay. Here, when you consider this 10 to 15, the middle will be somewhere here. Yes. Next, when you take 15 to 20, the middle is here. That is 15 to 20, 17.5, where 17.5 lies is the middle. How do we get the 17.5? For example, we are taking 10 and 15 interval. The lower limit is 10 and the upper limit is 15. We will be adding lower limit and upper limit divided by 2. So, we will be getting in this case 12.5, and 12.5 is at equal distance from 10 and 15. So, that is a midpoint. When it comes to 20 to 25 interval, what is the midpoint in this case? 22.5. Here we will be having 22.5. 25 to 30, 27.5. 30 to 35, 32.5. 35 to 40, 37.5. Okay. Now, join all these midpoints. You will be getting the required cumulative frequency curve. So, start from the 0. Okay, we will be drawing a freehand curve, not straight line, just this is a freehand curve. So, this is the required cumulative frequency curve or ogive. Okay, understood? Either you can do like this or you can find the class mark. From this class interval, we will be finding the mid values. Mid values for this interval. Here, this interval will have a mid value 12.5. Here you will be having 17.5, here 22.5, here 27.5, 32.5 and 37.5. With these values also we can draw the same curve. Just plot the points. That is for the interval 10 to 15. You're having a frequency 10. So find where 10 lies and where 12.5 lies. Mark the point. Here you will be getting the point. For every intervals, mark these points and join them to get the freehand curve. Understood this problem? Okay. Problem number 3. Question 3 of exercise 23. Draw an ogive each of the following distributions. Marks obtained is given and number of students is given. Here you have to note the interval is not given. What is given? Less than 10. If the exam is for 50. Okay. The exam is conducted for 50. Students who scored less than 10 is equal to 8. Students who scored less than 20 is equal to 25. Less than 30 is 38. Less than 40 is 50 and less than 50 is 67. What does this mean? Yes, here we have less than 10, 8 students. These 8 students will be included in less than 20. Yes, if a child scores a mark 8, okay, his mark is 8. What does this mean? 8 is less than 10, 8 is also less than 20, 8 is less than 30, 8 is less than 40 and 8 is less than 50. So, in every one of these, the mark will be included. Okay. So, less than 20 means less than 10, the marks also will be included. The marks of the students and the number of students will be included here. Okay. Less than 30 means it can include marks 5, 12, 17, etc. That lies between less than 10, less than 20, all lie in less than 30. Okay, so here this 8 is included in this 25. 8 and 25 is included in 38. 8, 25 and 38 are included in 50. 8, 25, 38 and 50 are included in 67. So when you take this less than 50, between the range 40 to 50, how many students have scored the marks? Here already 50 is less than 40. Okay, only the remaining students, that is the remaining 17 students have scored between 40 and 50. Okay, since the mark is less than 50, it means all these students, that is less than 10, less than 20, less than 30, less than 40 will be included here. That's how we get 67. Here when you check these frequencies you can see they are increasing. Yes. Okay, let's draw the ogive. So here we have the x-axis and y-axis. On the x-axis we are going to plot marks obtained. Okay. And on the y-axis we will be plotting number of students. Now check the values here 10, 20, 30, 40, 50. Therefore, we can put the intervals 10, 20, 30, 40, 50. Now check the frequencies. So these frequencies are known as cumulative frequency. Okay. So this value is included here. These two values are included here. That is when you add up you are getting this. Clear? Now here we have 8, 25, 38, 50, 67. 67 is the highest value and 67 should be included here. So when I start with 10, 10, 20, 30, 40, 50, 60, 70. Up to 70 is enough because 67 is less than 70. Now, let us plot the required organ. Okay. So, first, less than 10. Here we have 10. Okay. The number of students is 8. Where do we have 8? 8 is somewhere here you will be having 8. So, this is a point. Okay. Next, less than 20. Less than 20 it is 25. Where do we have 25? 25 lies between 20 and 30. Okay, between 20 and 30. Here you will be having 25. Next, less than 30 it is 38. Where do we have 38? 38 is just below this 40. Okay. Less than 30, you have 38. Next, less than 40 it is 50. Here we have 50. Less than 40. So, at 40, you will be getting 50. Next, less than 50 it is 67. Here we have 50 and 67 is just below 70. Now we'll join these. So when you join this, you don't need to use straight lines. Don't use a scale or anything like that. Ruler. Just with free hand you can join these points. You will be getting the required ogive. Okay. Understood how we have drawn this? Yes. Problem 5. Question 7 of exercise 23. Use graph paper for this question. Wages are given in rupees. A number of workers are given. 6,500 to 7,010. 7,000 to 7,518, 7,500 to 8,022, 8,000 to 8,525, 8,500 to 9,017, 9,000 to 9,510 and 9,500 to 10,008. Okay, so these are the frequencies. Now, what we have to do? We have to consider this table. Using the table, calculate the cumulative frequencies of work. So, this is the first question. Okay, here what you have to do is you have to make columns. The first wages, second number of workers, that is frequency, and then cumulative frequency. Okay, so here I don't have space, so I have just included a row here. Okay, so when you make first to the left end, it is wages, second column frequency and the third column cumulative frequency. Now how to find the cumulative frequency? Yes, just by adding these values, you will be getting the cumulative frequency in each stage. So, 6,500 to 7,000, the cumulative frequency is 10. Okay. Next, 7,000 to 7,500, when it comes, what you will have to add? You have to add 10 and 18. 10 plus 18, 28. That is, these values lies between 6,500 and 7,500 comes here. Okay. Next. To get the value here, we have to add this 28 and 22, which is 50. That is, the values will be less than 8,000. Okay, more than 6,500. Next value, 50 plus 25, 75. Okay, less than 8,500, more than 6,500. Next, adding 17 to this, you will be getting 92. Adding 10 again, you will be getting 102. Adding 8, you get 110. So, these are the values. So, we have obtained the cumulative frequencies. What does this mean? Here, already it is given that between 6,500 and 7,000, the wages are between 6,500 and 7,000 for 10 workers. When it comes between 6,500 and 7,500, there are 28 workers. That is between 6,500 and 7,000 and 7,000 and 7,500 will be included in this. Now, when it comes to the third one, how do we get 50? We get 50 by adding 10, 18 and 22. That is the workers between 6,500 to 7,000, 7,000 to 7,500 and 7,500 to 8,000 will be included here. Okay, so the first step is complete. Now, second part, you have to draw a cumulative frequency curve. Given that you have to use 2 centimeter is equal to rupees 500, starting the origin at rupees 6,500. Okay, on x-axis and 2 centimeter equal to 10 workers on the y-axis. Now, here we have the x-axis and y-axis. Clear? On the x-axis, we will be taking wages. On y-axis, we will be taking cumulative frequency. Okay. So, here 2 centimeters is equal to rupees 500. So, in a graph, we know that 1 centimeter, 2 centimeter, 3, 4, 5. This is how the boxes are. Okay. Here you will be having one box, first box. If you draw an axis. So, this part will be 1 centimeter. This part will be 1 centimeter. So, 2 centimeter means you have to consider 2 boxes. Okay. So, in these 2 boxes, this part is 2 centimeter. Okay. Here, so here on this axis, this is 1 centimeter and this is 2 centimeter. So, 2 centimeter is equal to rupees 500. It is given that we have to start from rupees 6,500. 6,500 should be the origin. So, this point, this 2 centimeter distance will be marking 6,500. So, every 2 centimeter, you will be getting next value 7,000. 7,500, next 2 centimeter 8,000, 8,500, 9,000, 9,500, we need up to 10,000, 10,000. Okay. Next, cumulative frequency, it's given that 2 centimeters is equal to 10 workers. Okay, every 2 centimeter will be marking 10 workers. So here we need up to 110. Yes, up to 110 we need. If we start with 10, this is 2 centimeter. Imagine this is 2 centimeter. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, up to 120 will be marking. Okay, so every 2 centimeter, this is 2 centimeter distance and this 2 centimeter is equal to 10 workers. Okay, now let us mark the values. So first 6,500. So we are starting with 6,500, less than 6,500 every value, that is we are not including or representing them. Okay, so 6,500 to 7,000 means less than 7,000, the values less than 7,000 and above 6,500 are included. That is 10. Here the cumulative frequency is 10. So here at 10 will be marking. So 7,000 will be getting 10. Okay. Here 6,500 is the origin. The first point will be marking for 7,000. Okay. That is less than 7,000. It means 10 workers are having wages less than 7,000. So the next is 28. 28 means less than 7,500. Here we have 7,500. Where do we have 28? 28 lies between 20 and 30. Somewhere just below 30 you will be having 28. It will be here. Okay. Next 8,000. 8,000 less than 8,000 we have 50. Where do we have 50? This is 50. Okay. 50 and 8,000. This is the point. 8,500. 75. Here we have 70, this is 80, so 75 somewhere here you will be getting, that is 8,500. Okay. Next 9,000, 9,000 it is 92. Here we have 90, 92 lies somewhere here and at 9,000, 92. Next 9,500, less than 9,500 you have 102. This is 100, somewhere here you will be having 102, at 9,500, 102. 10,000 less than 10,000 you have 110. 110 here we have 110. At 10,000 we have 110. Okay. Now join all these points. Draw a freehand curve. Starting from the 6,500 to this point. So this is the required cumulative frequency curve. Understood how we have drawn this? Clear? Problem number 6, question 9, sub-question 1 of exercise 23. Construct a frequency distribution table for each of the following distributions. Okay, here marks are given. This is less than, that means here 0, 10, less than 10. Okay, less than 20, less than 30, less than 40, less than 50, less than 60, less than 70, less than 80, less than 90 and less than 100. Okay. Then the cumulative frequencies are given. Cumulative frequencies, what does cumulative frequency means? All the values will be included. Here if it is 7, this means from 0 up to values which are less than 10 will be included here. When it comes to 20, less than 20, it means less than 20. Less than 20 means 28, where the 7 will also be included in this. Okay, less than 30. Less than 30 means all these values will be included. That is, this 7, this 28 will be included. Already this in this 28 we have 7. This 28 will be included here. Okay. Next, when it comes to less than 50. So here, this 54 peoples will be included. And here we have 71, which means less than 40. Less than 50. Everything will be included to get 84. Okay, so first we have to construct a frequency distribution table. That is, we have to find frequency. Clear? So here, the first column, you have marks. In the second column, you are having cumulative frequency. We have to find the frequency. Okay, this is what a frequency distribution table is. We have to find the frequency F. Put the values, marks. So first 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Cumulative frequencies are given 0, 7, 28, 54, 71, 84, 105, 147, 180, 196 and 200. Okay, now how to find frequencies? To find frequency, you just need to subtract the values. Okay, here we have already 0, that is 0. To get the second one, that is less than 10, you have to subtract this cumulative frequency from this cumulative frequency, that is 7 minus 0. Okay, to get the next one, from 28, you will have to subtract this 7. 28 minus 7. So, just use the logic here. If there are 7 people with marks less than 10 and 20 people with marks less than 20, what does this mean? This 7 is already included in this 28. So, when you remove the 7 people, you will be getting students who have obtained marks less than 20 and greater than 10. That is 28 minus 7 equal to 21 will be there. Okay. If you have 54 people, 54 students have obtained marks less than 30, in that less than 20 and less than 10 will be included. Okay. So, this less than 20, 28 people should be removed from this 54. Only then you will be getting greater than 20, less than 30. Okay. So, this is how we will be getting the frequencies. So, 28 minus 7. Next, 54 minus 28. 71 minus 54. Next, 84 minus 71. 105 minus 84. 147 minus 105. 180 minus 147. 196 minus 180. 200 minus 196. Okay, when you subtract this, we will be getting the required frequencies. This is 0. 7 minus 0 is 7. 28 minus 7 is 21. 54 minus 28, you will be getting 26. Okay. 71 minus 54, that is 17. 84 minus 71, you will be getting 13. 105 minus 84, you will be getting 21. Okay. Then 147 minus 105, you will be getting 42. Next, 180 minus 147, that is 33. 196 minus 180 is 16. And 200 minus 196 is equal to 4. So, if you want to check if the values we have got, the frequencies we have got is correct, what you have to do is just add all these frequency values. Okay. And you have to get this 200. When you add all these frequencies, if you are getting 200, then your answer is correct. So, when you sum up this, you will be getting 200. So, this is how you can find frequencies when cumulative frequency is given. When frequency is given, you know how to find cumulative frequency. What we are doing? We are just adding them, to get the next values. So, when it comes to frequencies, to find frequencies, just the reverse process, you will have to subtract from each. Clear? Understood this? So, this is how you can construct a frequency distribution table. And this is less than, remember this is less than, here less than 10, less than 20, less than 30, this is how the values is. Okay. Problem number 7, sub-question 2 of question 9, exercise 23, construct a frequency distribution table for each of the following distributions. Marks are given, now it is more than, in the previous question it was less than. More than means more than 0, more than 10, more than 20, more than 30, more than 40, more than 50, more than 60, more than 70, more than 80, more than 90 and more than 100. Okay. So, the cumulative frequencies are given. This means 100 students have got marks more than 0. Okay. 87 students have got marks more than 10. 65 students have got marks more than 20. 55 students have got marks more than 30. 42 students have got marks more than 40. 36 students have got marks more than 50. 31 students more than 60, 21 students more than 70, 18 students more than 80, 7 students more than 90, 0 students more than 100. More than 100 we cannot score marks. The exam was for 100 marks. Now we can construct the columns. First column, the marks. Second column, we have the cumulative frequencies, more than cumulative frequencies, and we have to find frequency to construct the frequency distribution table. Okay, so the marks, more than marks, we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Okay, next the cumulative frequencies. Here it is 100, 87, 65, 55, 42, 36, 31, 21, 18, 7, 0. Now the same step here again you have to subtract. Now in order to get number of students whose mark is more than 0 and less than 10. How do you find? Less than 10, more than 0. How to get? You will have to subtract this 87 from 100. So these are the steps. You have to subtract 87 from 100. Then you will be getting number of students who have scored marks which is more than 0 but less than 10. Maybe 5, maybe 4, maybe 3, maybe 6. Okay, these marks. Next, to get the number of students who have scored marks which is more than 20. So now, in order to get the number of students who have scored marks that is more than 20. Here it is given 65 students have scored marks which is greater than 20. Okay, how will you be getting? You will have to subtract this 65 from 87. 87 minus 65. Next is 65 minus 55. 55 minus 42. 42 minus 36. 36 minus 31. 31 minus 21. 21 minus 18. 18 minus 7. 7 minus 0. And here anyway it will be 0. Okay. So the first one, 100 minus 87, you will be getting 13. Next, 87 minus 65, you will be getting 22. 65 minus 55 is 10. 55 minus 42, again 13. 42 minus 36, that is 6. 36 minus 31, 5. 31 minus 21, 10. 21 minus 18, 3. 18 minus 7, that is 11. 7 minus 0, 7. Here it is 0. Okay. You cannot score more than 100. Okay. Understood? So, these are the required frequencies. So, when it comes to the more than case, this is how the subtraction should be done. When it is the less than case, from this value, you will be subtracting this value. When it is more than, from this value, you will be subtracting this value. Clear? That's all for today. In today's class, we have studied how to construct histogram, frequency distribution table and how to draw cumulative frequency curve. Hope you all enjoyed this. We have solved many questions from exercise 23. There are a few more questions left which you can solve on your own. I'll be back with a new chapter in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.